Okay, dokes, Martin. The example from this morning was done in a hell of a rush, so I took a stock job that I'd done a while ago and quickly pathed it up. I tried to do a full explanation, but due to the retarded limitations on YouTube, I'm not able to fit it into the time space. So I've pre-rendered all the paths, and I'm going to do an explanation of what I did with them. So what we were wanting to do is, let's hide that, and let's show you what my geometry is. I've got a head section that really, that's at about 30 degrees, that's at about 30 degrees, and this is at 0 degrees, right? So if I try to cut this as a straight index down, what I'd end up with is this angle here wouldn't be cut out. All these claws need to be accessed in that direction, otherwise what's going to happen, the tapered cut is going to come down like this, and I'm going to end up with all this unfilled area over here. These splits in between the claws over here are not going to be cut out either, those little splits over there, because the cutter's not going to be able to get in because the angle's wrong. So this is not the best example in the world, but it's a little bit better than the one I did this morning. I had some system failure while recording the original video, so I'm going to jump through this one quickly if you don't mind. What I did is, as per the video of this morning, I drew a curve, I extruded it, and I did a dupe face border to generate these outside areas here. I did the same thing for the bottom, and the bottom, and I'm going to show you how I implemented them. I'm going to show our ground plane. By now, because using visual mill, you will know that you do need a ground plane. Alright, so we're going to cut the top sections first. I'm going to move this ground plane down. Basically what the ground plane does, as you should know by now, is just stops your cutter going, plunging all the way through and hitting your table. The very first thing we needed to do, this is my series of index cuts for the top. Okay, so let me run through what happened. The first thing we needed to find out, of course, was what is the angle. The way that you do this in Rhino is to draw a line straight up and then draw a line perpendicular to your head section and measure the angle between them. I calculated this at being at about 30 degrees. So the first thing we need to know about our rotary is that 0 at our rotary is facing point up. 0 is also right around the circle 360, so anything to the left of it is 360 minus the degrees, anything to the right of it is 0 plus. All right, so our first operation was to rotate the table. Now you can see, look at our world coordinate system. I ran, let's open this up and have a look. I did a table rotation angle of 330 degrees, which is 360 degrees minus 30, and as you can tell from the world coordinate system, the blue arrow there, it's now pointing skew 30 degrees off center, which happens to be perpendicular to this setting over here. So once I've done that with my ground plane in place, and this is my constraining curve, I wrote this path, and as you can tell, what's happened with that path is it's running straight down. So it's getting in there, it's cutting all the little sections in there, it's hollowing out in between my claws for me, and of course it's also cutting away this. I did this with a very rough step over just to make it path quickly. So the next thing we needed to do was obviously come in and cut this. We don't want this cut at that angle because we're gonna have all kinds of problems here, and we're not going to be able to access behind the claw, so we need to rotate the table back up to 0. So the next operation, as you can tell, was rotate the table to 0. Okay, as you can tell by your world coordinate system, we're back at 0. Then write the path for 0, which, as you can tell from the angle of the path lines, came straight down as expected. The final path for the top section over here was obviously to cut the last section here. So guess with me, rotate table to 0 plus 30 degrees, which would be 30. Okay, and as you can tell from your world coordinate system, that's perpendicular to this head, and we wrote a path. Boom, job done. Okay, so concatenate it together. It can be posted in one movement, post, alright, and cut as one. Obviously you would have to have roughed this before the time with a bigger cutter with a skin of maybe 1 mil or whatever it is, because if you try and plunge through an 8mm block at an angle like that, you're going to kill cutters. Alright, now we've got to cut the bottom. This is not the best example. I'm going to assume that you had some detail that you needed to access at the bottom at the right angles. Okay, so don't work with the geometry I've given you. The first thing we need to do, of course, is realize that we're working 180 degrees around the clock. So all these angled offsets have to be, instead of from 0 now, have to be from 180. And of course we need a ground plane again. So we're going to rotate, we're going to move our ground plane upwards over the head section like that. So that's our new ground plane, because we're now going to be cutting from the other side. Alright, so in the index bottom section, my first rotate table operation was to 210. 210 is derived by 180 degrees plus 30, because we know that this is 30 degrees out. Alright, so we went to 210 degrees, and that is now perpendicular to this section of head. This was our constraining curve. Okay, you can see from our bottom section I've had them slightly overlapping, because from the top they're going to all access, from the bottom overlapping works a little bit better, I find. I don't know, depends on you, you're going to have to see what you want. So then we wrote a path. Whoa, that's because I haven't got my dongle plugged in. Alright, so then I wrote this little path, which as you can tell from the entry and exit lines is perpendicular to this, so everything's cut beautifully. The next rotate table operation had to go to 180, 180 being 100% down. Alright, so let's get our world coordinate system. So as you can tell, we're coming straight up. Wrote a parallel finishing path for that. And finally, our last rotate table was perpendicular to that, which would be 180 degrees minus 30, giving you 150. Alright, so we wrote a path for that. And let's examine all the paths together. We can hide that guy, and let's switch on our index top. So that's all of them together, cut beautifully. Okay, and this is all the bottom ones together. Okay, now you could have cut this as a plain rotary, assuming it was attached to a ring, but in my case for this ring there was a considerable other amount of geometry going in, little curved collet sections, so there's just no way I was going to access everything, so I decided to cut these separately and to cut the ring as a three-sided flip plus rotary, and then add these in afterwards. So I hope this has been a little bit useful to you. I'm trying to keep this short enough to go onto YouTube. Cheers, mate. Bye.